Intelligence and economic war games point to a specific catastrophic scenario, a sudden military blockade of the Taiwan Strait by the People's Liberation Army. Within 72 hours, maritime traffic through the strait freezes. 50% of global shipping containers halt in the water, instantly severing the export of advanced microchips. The disruption triggers an immediate contagion effect. Global financial markets lock up as traders price in the sudden collapse of the high-tech supply chain. Modeling of the first year shows a $10.6 trillion hit to the global economy. That is a 10.2% wipeout of total GDP, a contraction more than double the severity of the 2008 Great Recession. This global economic vulnerability is localized to a single island, a geographic choke point where the world's most advanced manufacturing is concentrated. Electronics manufacturers do not maintain safety buffers of advanced silicon. Because of the extreme costs, tech companies operate on a just-in-time model, carrying only 2 to 4 weeks of inventory at any given time. Once those stocks are exhausted, global industry stops. Modern vehicles require between 1,000 and 3,000 chips each. Without them, assembly lines in Detroit and Stuttgart would go dark in less than a month. The vacuum extends to national defense. Production of American precision weapons and the build-out of AI data centers depend entirely on a silicon pipeline that would effectively cease to exist. Taiwan deliberately engineered this lack of redundancy, transforming a supply chain vulnerability into a strategic survival mechanism. In the mid-1980s, Taiwan faced severe diplomatic isolation. After the United States ended formal recognition of the island, Taipei realized that military alliances were no longer guaranteed. To survive, they recruited Dr. Morris Chang, a former Texas Instruments executive, to build an industry that would make the island's existence existentially necessary to the Western world. Chang's brilliant innovation was the pure-play foundry. Unlike his competitors, he promised that TSMC would never design its own chips, it would only manufacture them for others. This birthed a new generation of fabless giants like Apple and NVIDIA. These companies could focus entirely on design, relying on TSMC to handle the multi-billion-dollar burden of physical manufacturing. This concept became known as the Silicon Shield. By monopolizing the digital world's manufacturing layer, Taiwan forced the United States and its allies to defend the island for raw national survival. Today, that shield is nearly impenetrable. TSMC controls 90%. Without TSMC's technology, hardware for the AI revolution cannot be built. Competitors cannot buy their way in. The barrier is yield physics. Manufacturing at the 3-nanometer scale requires manipulating matter at the atomic level. While rivals struggle with low yields, TSMC maintains stable production rates above 70%. This is the result of the Hsinchu cluster, a hyper-dense network of specialized engineers and suppliers that can reach a failing machine within 20 minutes. This atomic monopoly creates a dual deterrence. It handcuffs the American economy to Taiwan's defense, while trapping China's own technology sector in the same dependency. Fearing this single point of failure, the United States passed the $52.7 billion CHIPS Act, a massive federal effort to reshore semiconductor manufacturing to American soil. As part of this effort, TSMC agreed to build a $65 billion megafab complex in Phoenix, Arizona, intended to manufacture its most advanced chips domestically. But the project has faced severe friction. Construction and labor costs in the U.S. are up to 50% higher than in Taiwan, and attempts to implement East Asian work-life standards have led to public clashes with American labor groups. Recreating the hyper-dense, specialized ecosystem of Taiwan in the Arizona desert is proving to be an exercise in extreme financial and operational difficulty. These delays highlight a grim strategic question. What happens to these facilities if the island is actually occupied? To prevent the fabs becoming prizes of war, they integrated a remote kill switch into the advanced lithography machines. Through an encrypted signal from the Netherlands, ASML can remotely lock the mirror optics. The $200 million machine instantly becomes an inert 180-ton metal block. The physical delicacy of the fabs provides a second layer of defense. The shockwave of nearby artillery or a simple interruption of the power grid would ruin the cleanrooms, making the facility useless to an occupying force. These contingencies guarantee a Pyrrhic victory. Beijing could physically conquer the territory, but they can never claim the silicon prize. The American drive for self-sufficiency creates a direct conflict with Taiwan's security strategy. If the silicon shield is built on the West's absolute dependence on Taiwanese fabs, then successfully reshoring that production to Arizona and Texas actively erodes the shield. This creates a dangerous window between now and 2030. If Beijing perceives that Washington's commitment to defend the island will fade as domestic fabs come online, they may see a narrow opportunity to act before that leverage is gone. It is the ultimate irony of the Silicon Age. The desperate attempt to resolve the world's most dangerous choke point may be the very thing that triggers the conflict.